I know you're excited for this, yet another installation in the Stoichiometry video series. Hold back your excitement. Yay! Okay, seriously. So, what we have mastered so far is you have mastered the gram, mole, gram problems. You should be awesome with these now. Whether you're doing big old dimensional analysis problems, or whether you're doing the chart where you go down divide, across multiply, up multiply, no matter which one you're doing, you should have mastered these by now. If you're still struggling, you need more practice. You may need to come see me, heaven forbid, but you've got to master these before you move on. So, get some practice with those if you need to, and then come back. Are you back? Okay, so here's what we're going to talk about today. Today we're going to talk about this idea of limiting reactants. Believe it or not, we do not live in a perfect world. I know that shocks you because you're perfect and I'm perfect, but the world around us is not. Usually, if you go to make cookies, you are not going to have the exact amount of ingredients. For example, let's say, and I totally don't know this recipe off the top of my head, but let's say that Nestle Toll House chocolate chip cookies calls for 1 teaspoon of vanilla and, I don't know, 3/4 a cup of brown sugar, among other things. Okay? So that's just 2 of the ingredients that are in there. But you decide you want to make some cookies, and as you go to make the cookies, you open up your cabinet and you've got a full bottle of vanilla. Check! You got plenty of chocolate chips and flours and regular sugar. Did I say flowers? Make that flour. You know, the white stuff, not the stuff with the pollen. You got plenty of that. You've got eggs. You've got butter. You've got everything else. And then you get to this. And when you open up the cabinet, you realize you just don't have as much brown sugar as you thought. So let's say you've got plenty of everything else, but you only have 1.5 cups of brown sugar. That's going to be your limiting reactant. That's going to control how much or how many cookies you can make. It's just like some of the examples we were doing in class. Okay, if you have, let's see, we were talking about the Coke floats. The Coke floats, you needed 2 scoops of ice cream, you needed 1 cup of Coke, you needed 1/2 teaspoon of vanilla, and you needed a cherry. Okay, if you had buckets of ice cream, bottles of Coke, jars of vanilla, which I totally forgot to write in here, but you only had 3 little cherries. Okay, 1, 2, 3. Yeah, it's Friday afternoon. I'm getting a little giddy. Just go with it. Okay, if that's all you had, you are now limited to 3 Coke floats, even though you have plenty of ice cream, plenty of Coke, plenty of vanilla. This is your limiting reactant. So, I'm going to make it harder. Let's go to chemistry. When you're looking at this in chemistry, it's the exact same thing you do in a recipe. So, here's my recipe. I'm going to stick with the same one I've been using for all of these videos. 2 sodiums plus 1 chlorine yields 2 NaCl. That's my recipe I'm going to use. 2 sodiums, 1 chlorine, 2 salts. Simple recipe. So sometimes this can be easy. If I give you numbers and say you have 6 NAs and you have 1,310,473 chlorines, I think it's pretty obvious that is what's going to limit you. You're not always going to get that lucky. In fact, you're rarely going to get that lucky. More often than not, what you see with these problems is... Dun, 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 dun. Let me write the reaction here. You will see something along the lines of you have 21.2 grams of sodium and, we'll say 31.2 grams of chlorine. What is your limiting reactant? Now, I know what you want to say. You want to say, well, hey, there's less sodium, so that's got to be it. But it's not going to be that easy. Just because the number's lower, that's not what makes it limiting. It's instead about how much of this you can make. So what do I have to do to solve this problem? I have to do 2 gram mole mole or gram mole mole gram problems. You can actually set them up either way. You can do the dimensional analysis or you can do the chart. For simplicity's sake, right now, I'm going to do the dimensional analysis. On the next screen, I'll do the chart. So, here's my dimensional analysis. Okay, I'm going to go ahead and I'm going to do a full gram mole mole gram. I don't have to. I could stop at mole, but I'm a glutton. So, 21.2 grams of sodium. I'm going to go all the way from grams of sodium to find out how much sodium chloride I can make. So, go from grams of sodium to moles of sodium. This is exactly what you did before. 1 mole from the periodic table is 23 grams. Then I'm going to go from moles of sodium to moles of NaCl because I want to find out how much of it I can make. These numbers right here come out of the balanced equation. So next to the NaCl there's a 2, next to the Na there's a 2. You could make that 1 to 1, it doesn't matter. Mathematically it's the same. Now I'm going to go from moles here to grams here. Again, this is a gram, mole, mole, gram problem. So, periodic table, I know 1 mole of this. When I add these up, that's 23, that's 35.45. I get 58.45. Hopefully you can read that. So now I'm going to calculate this out, and what I'm going to get is 53, and I'm actually going to write it up here since I'm running out of room, 53.88 grams. That is my answer. So what I've just figured out is from 21.2 grams of sodium, I can make 53.88 grams of NaCl. It's great. Still don't know what my limiting reactant is. So now I have to look at my other ingredient. Yes, boys and girls, children of all ages, limiting reactant problems involve not 1, but 2 problems to be solved. Because now I'm going to start with my chlorine. And I'm going to say, okay, with this much chlorine, how much salt can I make? So again, I'm going to go through the exact same process. I know you're excited about this. I'm going to go from grams to moles. 1 mole of chlorine, it's 35.45, but it's diatomic. There's 2 of them. So my molar mass is 70.9. Then I'm going to go from my moles of chlorine to my moles of my salt, my NaCl, because again, I want to know with this many eggs and this much brown sugar, how many cookies can I make? So, go to the balanced equation. There's a 2 there. There's a 1 in front of my Cl2. Then I'm going to go from my moles of my NaCl to my grams of my NaCl. And I'm going to do, once again, 58.45 and 1. So this time, when I put it in my calculator, I get 51.44. Sorry about that screen blip. My hand just hit the wrong thing. So 51.44 grams. So, with all of this work, here is what I've just figured out. If the question said, here's my recipe, these are my ingredients, which one is going to limit how much I can make? Which one's going to hold me back and control how much I can make? So if I look at them, if I start with 21 grams of sodium, I get 53.88 grams of salt. If I start with 31 grams of chlorine, I get 51. This is a lower number than this one. So whichever one produces the least amount is my limiting reactant. So the answer to this question would be chlorine. The limiting reactant here is Cl2. It's not the lower number I started with, but it produces the least amount. Let's go away from chemistry for a second. Let's go back to food, because y'all like food. Okay? 2 pieces of bread plus, we're going to be nice. I don't know about y'all's peanut butter sandwich. In my house, peanut butter goes fast. But we'll say 2 pieces of bread plus 4 tablespoons of peanut butter. I know, I'm dreaming, but I know for some of y'all it's half a jar. That makes 1 sandwich. Okay? So let's say I'm kind of hungry, and I go through my house, and I have 16 tablespoons of peanut butter, and I have, I don't know, 32 pieces of bread, because I'm just that kind of person, and I just counted how many pieces of bread I had. If I want to know what the limiting reactant is, here's what I'm doing. I'm saying, well, with 16 tablespoons, I don't know why I put that B right there. I did that twice. Let's make that go bye-bye. Okay, with 16 tablespoons of peanut butter, that's what I wanted. Okay? It takes 4 tablespoons per sandwich. I can make 4 sandwiches. Yes, I call them sandwiches. Get over it. Then, let's say my 32 pieces of bread. If I have 32 pieces of bread, it takes 2 pieces of bread per sandwich. I can make 16 sandwiches. So what's my limiting reactant? Obviously, my limiting reactant is my peanut butter. If I flipped the question around and I said, how much could you make? The answer would be 4 sandwiches. So you can actually do the same thing here. Instead of asking, what is the limiting reactant? Let me change that color. Okay, instead of asking this question, maybe I could say, how much salt could I make? So if this question went bye-bye and we replaced it with how much salt could I make, your answer would be right here. It's whichever one produces the least amount. Now, on a side note, I told you I'd show you this with a chart as well. So we're going to use the same numbers, 21.2 and 31.2. But you can do this the exact same way with a chart. Okay, I got 2 sodiums, chlorine, 2 NaCl. And I'm going to make my chart. I got mass, I got molar mass, and I got moles. So this may be easier for some of you to write 2 different charts, because essentially what I have to do is start with my 21.2 grams of sodium and my 31.2 grams of chlorine. I'm going to have to take one path down, over, and up to NaCl. So my molar mass of sodium is 23. Then I start getting calculator crazy. 21 divided by 23, 0.92. Again, I'm keeping everything in my calculator. Times my mole ratio, what I'm going towards over what I'm leaving behind. That's going to be 2 over 2, so that stays 0.92. Then I have my molar mass here of 58.45. And last but not least, I'm going all the way up to the mass. So when I go up to the mass, I have to multiply times 58.45. And my answer is 53.88. Same thing it was before. But to find the limiting reactant, you've got to go one step farther. Now I have to do the exact same process with this 31.2. I have to take it down, over, and up. Some people will do it on the same chart. Other people like me, that's confusing. I can't do that. I need 2 separate charts. Whatever it is you choose to do, it will work. Okay, chlorine, 70.9. So if I take my 31.2 divided by 70.9, gives me 0.44. Stick that right down here where I can see it. Then as I go across, the coefficient I want over the one I'm leaving behind. So I multiply that times 2, I get 0.88. Then, same molar mass here, it's still 58.45. Multiply that out, and what do you know? I get 51.44. So the limiting reactant is chlorine. That's how you would answer that question. Or if the question asked what mass would you make, your answer would be whichever one is lower. It happens to be 51.44 grams. That's the idea of limiting reactants. This can be tough, and clearly when you look at it, this can be a lot of work. But it's straightforward. Just remember, back to food again. Okay? It's what's holding me back. What is preventing how many yummy, delicious snacks I can make. I know, it's sad. But you can do this. Just think about it. Figure it out.